Hello guys, welcome to my channel. Today you will learn all about polymorphism. And before getting started, please subscribe to the channel, like the video, leave some comment, and turn on notifications. This is the video from my complete course about Revit API and object-oriented programming. If you're interested, there's a pinned comment with the email you can reach out to me for more details. And now let's get started. Polymorphism. This is something that we cannot write our apps without, especially in OOP style using statically typed languages. And you may be like, what does it mean statically typed? There are statically and dynamically typed languages. C# and Java are statically typed, and Python and JavaScript are dynamically typed. Let's check out some examples. For example, here we have a simple method that's called add, and what it does, it adds two strings together. So it basically concatenates them. And here we're using C# language, and C# is a statically typed language. And as you can see, an indicator, a sign of a statically typed language is that here before the parameters that we're passing to the method or for the return type, we're actually saying what we should get, right? So we know that the parameter A should be of type string and the parameter B should be of type string as well. Let's check out the same example but using Python. So here we're saying that the method is called add, and we're just passing A and B. As you can see, we're not saying that A should be string and B should be string. And return, we're simply adding them. Here in Python, we don't say what we should return. As you can see in C#, we're saying what we want to get out of this method. And in that particular case, it's a string. But in Python, we don't say this. Let's use this method. For example, here I'm using this method for adding just some integers. For example, I'm passing 5 and 2, and the result is 7. Also, I can add text, strings. So I'm passing from, I'm passing to, and the result will be from 2. As you can see, it's kind of quite versatile. Let's check out the same thing using C#. So as you can see here, if we're using to and from, everything works correctly. And as a result, we will get to from. But when we use 5 and 2, our code cannot be even compiled. It's not even allowed because you have that agreement, you have that contract that this method add should accept a string, not an integer. And at first sight, you may think that dynamic programming is way much cooler, but it's not like that. And the simple answer why it's not like that, because here the compiler is not even less adding, it doesn't even let us do this thing, and that is safer because we have that contract that this method should accept a string A, a string B, and we can only pass what we told it to be able to be passed. But in that case, we can pass pretty much anything. It can be strings, it can be doubles, it can be integers, and it will figure out on its own how that should be calculated. At first sight, you may think that that is versatile, but down the road you'll have a lot of problems with that. So polymorphism is one of the most important concepts of object-oriented programming. A lot of patterns are based on polymorphism, and it's because of the polymorphism the object-oriented programming is so powerful that allows to reuse code and use the existing code to work with different data. I would actually put emphasis on that sentence, to use the existing code to work with different data. So that is actually the main thing that I want to convey to you today. So it's a concept that refers to the ability of a function to work with data of different types. And for the time being, it may not say a lot to us and may not kind of hint what it is. Before getting into all the examples and understanding the point of it, first of all, we need to know that there are two types of polymorphism. The first one is ad-hoc polymorphism. I hope I didn't slaughter the pronunciation of ad-hoc. And parametric polymorphism. Let's check out what does each of them mean. So ad-hoc polymorphism is a kind of polymorphism in which polymorphic functions can be applied to arguments of different types. The most common example is overloading. I'm pretty sure that you've seen this already. For example, here we have a very simple class called shape, and we can create that method draw. We can have the same name for this. As you can see, we have three methods with the same name. What changes is the signature. So we're basically saying that here we can call this draw method without any parameters. Here we can say that we can call it with one parameter that is called x and is of type double. And here we can call it passing two values of type double. And as you can see, that's the way we use it. We create an instance and now we can call it draw, draw, draw. And the compiler chooses an appropriate implementation for the method based on the types of the arguments. And here, what I really want to point out is the names are the same, but they're different. By they, I mean methods, but methods are different. They have different bodies. As you can see here, draw name is basically the same, but here we're actually having different bodies for this. That is actually not the type of polymorphism that gives us all that flexibility and power, but I just wanted you to be aware of that kind of polymorphism as well. And I'm pretty sure that you've already used overloading for constructors or methods. Now we're going to go to the parametric polymorphism, and that is the one that actually provides that power to object-oriented programming. It's when a function with the same body as opposed to ad hoc can work with data of different types. And now it's time for examples so you can totally grasp the idea of this. Again, getting back to our real world examples, let's suppose we have a wall, we have a roof, and we have a floor. Three different elements. So we may think, let's create a class called element, right? So we're going to have a class called element, and just for the sake, I put the property name here, but it doesn't that matter in that particular case. What does matter that we have this property of type element type. An element type is a simple enumeration which actually defines the type of the element. So that is the type wall, roof, and floor. And let's say where we're going to create them. Let's suppose in some sort of like a document. Let's say that we're building our own 3D application and user is going to double click on the icon. User is going to open or create a new document, and within this document, user can basically model walls, roofs, floors. And we're going to create a method like this. So we're going to have a class document, and that document will have a method called model element. And here we're passing just a list of elements here. And basically, we're going to use for each loop to iterate, to go through each of the element and do some action. For the sake of simplicity, I'm just gonna have, for example, here, I'm checking what is the type of element. So I'm going element, I'm reaching this property type, and I'm asking whether it's, for example, a wall, and here I'm defining the logic. Here I'm defining the algorithm. But keep in mind that in real applications, that algorithm is going to be complex and is going to take up a lot of space. So here we're checking if the type is wall, we're gonna print to the console a message drawing or modeling a wall. The same goes, we check if the type is floor, we're passing the message, and the same goes for the roof. And also, you can change this if with switch statements. When it comes to if versus switch statements, I prefer ifs because they're kind of easier to read for me. And the main question is, have we used polymorphism here? And actually not. I'm just showing you the example and a bad way of doing this. And now we're gonna fix it and understand how we can apply polymorphism to understand. First of all, we need to understand what problems we have here, and then how, with the help of polymorphism, we can fix them. So again, we have this method. So we have this class document. Within this class, we have a method called model elements. And here, actually, where the logic happens, we go through each of the element and based on its type, on its property type, we define the logic for drawing this, for modeling this. And the main question is, what is the problem with this code? Like, or is there any problem with that code? And to understand it, let's suppose that we want to add something new, because that is something that will happen all the time during the development. You're going to need to modify something or add new functionality. So let's say we want to create a new element, a table element, right? So we decided to add a new type. So what do we need to do? What changes do we need to make? So the first change is that we simply need to add that type. So we had wall, floor, and roof. Now we need to add table. And then we need to go to this method model elements from this document class. And now we need to specify one more else if and check if the property type of this element equals to table. And here we're going to define some logic for this. What is the problem with this? So every time we define a new element type, this model elements method is going to be changed. And the class that contains that model element, in our case, it's a document class, that class has to be recompiled. And the same goes for element type. So every time we add a new member, so in our case, we added a table, all classes that reference it should be recompiled. So that is a very crucial thing to understand here. And as you can see how many changes we needed to make to just add one more implementation for this. And again, keep in mind that here I'm just showing like a very simple logic for this. So I'm printing to the console a message that I'm drawing a wall. But in a real world application, you would need to have a lot of lines of code here to make it happen. So eventually, this method is going to contain plenty of lines, hence impossible to read and maintain. Because what is vitally important for us, what is really crucial, is that we can maintain that code. Because changes are inevitable. People want to add something new, and people want to modify something that you've already written. So this is the main problem. Each time when we need to add a new type of element, for example, in our case, we wanted to add a table, not only we need to, not only did we need to change, do we need to change this enumeration by adding a new enumeration. We also need to go to the model elements class and modify it here. And eventually you're going to have a lot of lines of code here. So how we can solve this using polymorphism, how that can be achieved. What we can create is that we can have this element class, but make it as an abstract. And if you're not familiar with what is an abstract class, Abstract class is the one that cannot be instantiated. So you cannot go and type something like this, new element. So you cannot create an instance of that class. And when that can be useful? When actually, because in that particular case, I want to have this method that is going to be called model because I want to leverage the power of inheritance and I want to have other element to inherit from that element and implement that model method. Let's see a quick example. So here I have a public class wall. I have a class wall that inherits from element and because this model method is abstract, the class that inherits from it must actually implement this method. So why am I not having it here? Because an element doesn't know how to model itself. Why? Because element is too abstract. We saw that we have something like a wall, a floor, a roof. These are they're different. And if we have something called element, these this one is too abstract. The element, it's like having some sort of like a shape. Shape can be a triangle, a circle, a lot of shapes we have. And based on that shape, for example, a triangle differentiates from the way the circle is modeled. So we should keep that in mind. And by saying that that class can be an abstract, we're basically saying that that class cannot be instantiated. So we cannot create we cannot type something like new element. And also within an abstract class, we can have abstract members. So as you can see here, I have something like abstract method, but what is actually different from something that we already know is that here, as you can see here, we are putting this square brackets and here we're defining an algorithm. Here we're putting our logic. But in this case, when we defined our method as abstract, we don't need to specify the logic because it doesn't have a logic. An element only knows that it should have a method called model, but that doesn't know how to create itself. So that is the responsibility of the classes that will derive from it. So in our case, we're saying that I want to have a method called wall that will inherit from element, and that wall class should actually know how to model itself. And as you can see, that's the way we create all these classes like wall, floor, and roof. So here, what is happening here that we have that abstract class that is called element. It doesn't know about modeling itself, but all the classes that derive from it should, not even should, but must implement the method model. So they should know how to model itself. So the wall knows how to model itself, the floor knows how to model itself, and the roof knows about this. Now let's go to the document class. So here what we have is that we have that method move elements and let's see what happens. Here we're just using for each loop and we're iterating through each of the element and we're simply calling a method called model and that's it. We don't have here like if switch statements. We just call model. And then in our application, we create a document. So here we're creating a document, and here we're creating a variable that holds all the elements. And we're just from the document call a method model elements, and we're passing all of these elements that we have, floor, roof, table, wall, and roof. And now when I run this, this is the result that I'm getting. Have modeling a floor, modeling a roof, a table, a wall, and again a roof. As you can see, what happens right now? So the main question right now is what we need to do to add a new feature, to add a new element type. For example, in my case, I want to have table, what it takes to add a new one. Basically, what we need to do is that we simply create a new class called table that inherits from that element, and it basically says what it should do. If you remember from previous things that to actually create a new type, we needed to go to that enumeration element type and define a new type there. And then we needed to go to the model elements method and change the logic here as well. But right now, our element is not changing at all. It has not changed. We simply created a new class table that inherits from that element. And based on the type of the element, we're defining the logic. So this is where the magic happens inside of this method. So it goes through each of the element, and here that element can be any type that derives from that element. So it can be wall, floor, roof, table, or more new types that inherit from our element class. So this is what I talked about at the very beginning of our lesson, that it can work, our function right now can work with data of different types. So now it can work with wall, with floor, with roof, and they all contain the implementation for the way they model themselves. This is why that is so crucial. So right now, it's very easy to extend and add new elements. And now we can model a lot of new different elements. For example, maybe you want to model a door or a window. So it's simply as going and creating a new class that inherits from element, and it will prompt you to implement that model method, and you're going to implement it, and that's it. Now let's practice with what we saw in the previous lesson. So don't worry about these regions. They're just for learning content to be stored. You shouldn't be worried about them. So here, again, as a good practice, as a rule of thumb, whenever you want to create a new class, you go to your document, right click, add, add a new item, and here you're creating a new class. You're creating actually a new class file, and here you can specify the name of this. Or you can use the shortcut Control Shift A. But I just want you to see everything within one place, so it's easier for you to get and grasp the information. So we talked about that we wanted to create something like something that is related to the real world. For example, modeling walls, roofs, and floors. So first of all, I'm going to create a public class, and here let's name this element. And here also I'm going to have an enumeration for different types like walls, floors, and roofs. Public enumeration, and I'm going to say element type. And here I'm going to have floor, wall, floor, and roof. And let's create a property. I'm going to use the shortcut prop, and I'm going to specify that that property should be of type element type, and the name of that property should be just type. And now we're going to have a document there. So where we're actually going to model everything, right? Where we're going to store all of our walls, floors, and roofs. So I'm going to have a class called document there. And here I'm going to have a method that is going to return void, and I'm going to say model elements. Oops, I forgot to put. And here, as a parameter, we're going to have, as you can see, when I'm using resharper, that actually not only hints where the type is located in which namespace, but also is gonna is gonna use the using keyword and import that namespace. So I'm gonna have list of the elements, and I'm gonna pass their elements. And now I'm gonna use a for each I'm gonna use a for each loop, and I'm gonna go through element, and here I'm just hitting the tab to actually do its job, let the resharper do its job, right? So it will even rename this temporary like variable for me, and it's just gonna put it in a singular form. So here right now is when all the tedious works come. So we go if element type, as you can see, it even helps me to kind of figure out what I want to do. So if element type is wall, I'm gonna put to the console something like modeling a wall. Then else if element is floor, I'm gonna say modeling a floor. And else if for example, element type equals to roof, and I'm gonna say modeling roof, modeling a roof equals. I forgot to put there like this. And now we go to our program class, the entry point over application or our basic console application, and I'm gonna say var document, new document there, and I'm simply going to go document model elements. But before that, we need to create elements. So I'm going to go var elements, new list of element. And here I'm going to put one element and I'm going to specify the element type for this to be a roof. Then I'm going to put a comma, and by clicking Control D, I can copy this to the next line. So roof, wall, and floor. And here I'm going to pass elements. I'm actually showing you the fast way of coding so you can actually see that you can code faster. It's really important for you to learn how to code fast. And now I'm going to click Control Shift B to compile the code. As you can see, the compilation goes, and now it was succeeded. And now I can click Control F5 to actually run this. And that is what I have. So now I'm modeling a roof, a wall, and a floor. Basically what it does, it goes through each of the element and it checks the type of this, and based on the type of the element, we have the logic. The main issue with this, as we saw in the previous one, is that if I want to add a table here, if I want to have an option to model a table, I need to add this to the element type. I need to go there, copy this, paste it, and say that if that is a table, and here change this to table. But keep in mind that again, in the real world application, modeling a roof and a table can differentiate a lot, and it may include a lot of logic in there. So keep that in mind. And now I can simply here, instead of floor, put a table, and now it's gonna say me that we're modeling a table. So each time when we want to add a new element type, we need to change this enumeration, and we need to change this model element method. Now we're going to see the power of polymorphism so we can leverage this. So first of all, I'm going to remove this enumeration at all. I don't want to have this, and I don't want my element to contain it. And if you remember from the previous lesson, I showed you how you can use an abstract class. Now I'm going to show you how you can use it without an abstract class and then show you some differences. So we have that class element. And what I want to do there is that I want to have a method, but I want to mark this with virtual. So what does it mean virtual? That the derived classes can overwrite the logic for the specific method. For example, I'm going to have a method model. First of all, I'm going to say what it should return. It should return void. And I'm going to have a method model. And in our case, that method should be empty because element is too abstract. It doesn't know how to model itself because element is way too abstract. It's like a shape. So a shape can be a triangle, a circle. So and they're modeled using different formulas and user different modeling techniques. So here I'm going to leave this method as empty, and now I'm going to create a method called wall that is going to inherit from that element And now to override, and actually, let's see what happens in that particular scenario. Let me kind of copy this and paste, and let's say that here I'm going to have floor. And here I'm going to remove all this, all these things. I'm going to click home, so I'm getting to the very left side, as you can see here. And I'm going to hold Shift key and click on the arrow down, and that is going to select the lines, and I can easily remove them. And now from each of the element, I'm going to click on model. So now instead of actually creating these elements, let's kind of create new element here. Then I'm going to create new wall, and I'm going to create new floor. Let's see what we're going to have in our console. And we have nothing whatsoever, because in that particular case, if we don't override this in our wall, if we don't override that model method, it's just gonna grab the default logic. So if I pass here some default modeling and run this again, for all of them, it's going to use this method default modeling. So what it does, it goes through each of the element. And for example, here our wall doesn't contain the method called model. So it's going to go to the base class. And in our case, it's an element. And that's going to use its model method. So what we can do there is that we can easily use override. And as you can see, the IntelliSense helps us and say, you can override the model method. And as you can see, by default, it's using the base model. So what it does, it says that I'm going to go to the base class, and the base class is the one that we inherit from. In our case, it's element, and it's just using this method. What we're going to do is that we're going to say modeling a wall. Now I'm going to copy this. I'm going to go to the floor class, and I'm going to also say override model. And here I'm going to paste this, but not modeling a wall. I'm going to say modeling a floor. And here, as you can see, we have our elements in our document. We have our elements, element, wall, and floor. We're passing them to the method called model element. So let's see what we have right now. So for the first element, it's using default modeling. For the wall, it's using just modeling a wall. And for the floor, it's using a floor. We already have the power of polymorphism. So here, if we want to add new things, for example, let's say we want to add a table there. So I'm just going to copy this portion. I'm going to just copy this portion, and I'm going to rename the class to table, and I'm going to say modeling a table, and I'm going to go down there, and here I'm going to add new table there. As you can see, if I run this, everything works. Here we have modeling a table. Our method model elements has not changed, and our element class itself has not changed, because what we need to do is to simply add a new class that inherits from that element and does the job. But in our case, we don't want to have that. We don't want to have an instance of an element class. It is too abstract. And what it used for is maybe contain some general information in it, and that's it. But model method, it shouldn't have that model method. Okay, of course, I can simply remove this, and when I run it, it will simply skip it because now we're not doing anything inside of here. But I don't want to be able to go and say new element. So this is where we can type abstract. So I can go public abstract class. And when I say abstract, that means that we cannot create an instance of that class. So if you hover over this, you will see that you cannot create an instance of the abstract type. So we cannot create that instance. And now instead of virtual, because here, why abstract class is so cool? Because here we can leverage the power of inheritance So basically to reuse the code, so I can say that I have property called, and I have like the name of this. I have a property, let's say, like integer ID. So here I have these properties and they're okay. Let's see, uh, let's say they have method. So for example, public void place, and I'm gonna say that placing an element. Let's say that here the place method is the same for all derived classes. For example, it's the same logic. So when we're placing a wall, it should be placing an element and that's it. They're all placed in our document using the same way. Now we're going to see actually the power of this. But here I don't want to make this as the virtual because I don't even want to have an implementation here because right now it's empty. And if I just make it that way, it's going to tell me that, you cannot do this. But if I, instead of virtual, say abstract, what does it mean that now all of the derived classes must implement it? Let's see how does that work. So let's create a new class called roof. Public class roof element element. And now even right now, it's gonna prompt me with a message that the model method is not implemented because here I marked this as an abstract. That means that all classes that inherit from element must implement the model method because it doesn't know how to model itself because element is too abstract. So with ReSharper, what you can do is that you can click Alt and you can go with the implement missing members. Alt and Enter and then implement missing members. And here we're going to define that logic. So modeling a roof. But what is a very cool thing here is that we can still use, for example, this, and we can use ID, we can use name, and we can use place, right? We can still use place there. So why I wanted to show you also the power of abstract classes is because here we can define some logic that is the same, so we can leverage the power of reusing our code and we would simply mark them with place. And if you want to give an option to the user to override them, you simply mark them with virtual. So right now, if for example a roof has a different way of placement, we can simply go override and override that place. But that is not a must thing, right? We can simply reuse that place there, but if we want, we can override. But model method must be implemented from all the classes that implement that element. So right now, let's, for the sake, just put there this place, right? So we can actually have place method inside of here. So everywhere we're gonna have this. I'm using this place just to show you the power that we can still uh, using abstract classes, we can still leverage the power of inheritance and and also have the power of polymorphism, which is actually here. So right now, to add new implementations, to add new logic, we simply need to create a new class, and we don't make any changes anywhere. We don't make any changes at all. So now it's telling me that you cannot create element because it's an abstract class. And if I run this, it's gonna tell me like this: placing an element, modeling a wall, placing an element, modeling a floor, and placing an element. For example, if you want to change this for the table and you go override placing, you can say placing a table. And if you run this, it's going to say placing a table. So not only did we learn a lot about polymorphism and how our function can get element with different types, right? So here, this element can be of a different type. It can be a wall, floor, table, and it performs some action based on that type. But also we learned the power of abstract classes, that here we can define some base logic, for example, the base logic for placement, that here we have a couple of properties, and also we can define abstract classes that must be implemented by classes that inherit from it. That's it for this lesson. I hope this was useful. Don't forget to subscribe to the channel, like the video, leave some comments, and turn on notifications. And have a nice day.